Hey class, today we'll be going over curtain systems, curtain walls, some complex geometry, and starting to get into how to take that complex geometry and break it down into actual constructible components. Um, so let's just get started with a opening or starting a new project, and then using the computational practice template to open it up. And then first we'll just go ahead, we can delete the roof. And we can just move level 2 up. You can either move it, click and drag. Doesn't need to be a specific height. Any height will do. And then go to a 3D view. And to create our more complex geometry, we're going to have to use in-place mass. So if we go up to massing in site and then hit conceptual mass, in-place mass, doesn't matter what name. And then what I wanted to do is use splines. So splines are up underneath the draw tab, little squigglies. And there's two different types. There's spline and then spline through points. Spline is your typical kind of NURBS curve. If you click, it'll draw control points that each have, and you just hit escape to stop drawing, each have their own control points. So the first and the last is going to be the endpoint, and then whichever points are in the middle, they become these control points that have weights to them and control the curvature of the curve. They're okay. Obviously, we'll use them today to create some more complex double curved surfaces, but they're a little tricky. There's a couple reasons why. One is that, if we drew another line and we tried to trim or extend to that curve, it's not going to do it. If we did it in Rhino, it would assume a certain tangent coming off this endpoint. It would trim or it would extend it out and meet that other line. But in Revit, it's just not set up to be able to be manipulated. If we offset or mirrored this curve, and make it larger so you can see where. So if we offset that curve, it does offset and it offsets correctly. Problem is when you click that offset curve, it loses all of the control points that are associated with it, and all you can do is change the location of the endpoints and either scale it up or down. And same thing with if you create a surface from it. It's very difficult to control. It's not really that manipulatable or malleable. And I try and stay away from it as much as I possibly can. If I have a multi-curved surface, I'll just draw what I can from true, oh boy, here goes squeaky. What I can with actual true radiused curves. But for the sake of today, we'll use spline, and let me go take that squeaker out of her mouth. Okay, no more squeaking. So we've created one. Now I want to create another one that has different curvature up at level 2. So I have created the first one at level 1. Now I want to set my placement plane or my drawing plane at level 2. Then go up and do the same thing. Oh, I'll show you. So that's typical spline through points. You actually have to have a series of points and then it will create a curve through those. So if we go over and select the point element and then draw a bunch of points and then highlight those points, just the points, and hit spline through points, it'll create a spline as best it can fit through those points. And then you can go in and manipulate the curve by moving the actual points themselves. All right, so now that we have our two splines, I'm going to put them somewhat close to on top of each other. That's good for now. And then to create a surface between these two curves, what I'm going to do is select the first one and then the second one, holding control, so I select both at the same time, and then go up at the top and hit create form. Now I've created a surface, double curved surface with the two different control lines at each point. And then of course you can go and see, this is, so one of the issues, not one of the issues, I guess, you can go and manipulate the endpoints. But when you do that, oh, this spline actually kept its, oh, it's because it was spline 3 points. All right, so we have it, manipulate it however you want. Get it to be nice and double curved. And then once you're done manipulating it, hit finish mask. Now we have double curved surface. Now the first thing I want to go over is curtain system, and we did that before in our conceptual mass tutorial. But I want to get a little bit more into specifics, how to manipulate it, how to create different types of curtain systems, facade systems, glass systems, or facade or shading, or glass, whatever we want. So click the double curved surface, or actually, excuse me, just click the curtain system, then click the double curved surface, and then hit create system. And it will create a faceted series of panels. Now, the thing that you gotta keep in mind, especially with curtain systems, is that while you can have double curved surface and complex curvature in your geometry, the panels themselves are always going to remain flat. So what they do is they orient themselves to the tangent of the center of the panel. So at the center of this panel, the tangent of the surface is in this orientation, and so it orients itself like that. So when you have really complex curvature like this, to get like a nice clean surface, you're going to have to subdivide it a little bit further. Now to do that, we've gone over how to create different curtain systems. Over on the right hand side, currently we have a 5x10, which I think we might have manipulated, but if we go in and we edit the type, it'll bring up this window. This is the same breakdown pretty much as a curtain wall. So you can select the type of curtain panel. So we can either hit solid or glazed. Join condition. This is whether or not to maintain one or two, or basically determines which mullions are going to be consistent all the way across and which ones are going to be broken. So you can start to specify those there. And then obviously layout is how we want it to actually break down the geometry. So right now we have a 5x10. We can change this to 5x5. We can also go in maximum spacing. So actually I'll do maximum spacing as well. So maximum spacing, it's going to subdivide this as close to 5x5 as possible, but it's going to subdivide it evenly. So it might be 4 foot and 8 inches, but it's going to be at most 5 feet, and it's going to be subdivided equally. So maximum spacing 5 foot, and then we can specify mullions. So we'll do the interior. Let's just do everything as rectilinear right now. And then we'll do squares for grid 2, 1-inch squares. Hit OK. All right, so now we have a somewhat evenly divided, and especially with the complex geometry, it essentially goes through and subdivides each grid at its point, which makes a nice kind of clean, consistent breakdown of the surface. And then we have our mullions. So our mullions are 2.5 inches for the more vertical mullions, and it looks like the 1 inch is our horizontal. So one thing I want to show you. So that's how to associate it through the family. If we go back to the family and let's change the interior grids, mullions of grid 1 back to none. Yep, want to delete the mullions. So I did that because I want to show you how to place it. So if you just had a grid and you wanted to only place mullions on certain grids themselves, what you can do is up at the top, under the architecture tab, under build, is curtain wall mullion. If you select that, then you can actually go in and select whatever kind of mullion you want to place in the drop down. So we'll do 2.5 inches, and then underneath placement, under modify, you can specify if you want to select all the remaining grids that don't have any mullions associated with it. So if we did that, it would do all of the vertical interiors. We can actually specify just one. So we can go in and click, and you can actually specify just the individual grids themselves, or you can do a whole grid line, which you can see there. If there are already mullions hosted to that particular grid, it's just going to do everything else within that line. And then of course, if you go in and select all, it's going to select and place on all the remaining non-associated grids. So showing you how to place them. Now, the nice thing with mullions, they're not just there to host glass panels for, right? You can use them as vertical fins, horizontal fins, different types of shading devices. So if we go in, and you can manipulate the geometry of them, you don't have to just use the preset sizes that come with this specific template, but you can go in and actually create custom geometries, and you can also create custom profiles as well. So let's go in, let's select one of the mullions we've placed, go to edit type, and let's hit duplicate, and let's just type in test, just because we'll do a lot of different stuff to this. So you can change the angle, the offset, which is how far or close to the center line of the curtain system, or basically where the face of the surface is if we're doing curtain systems by face. And then you can change where it is if you want it to be specifically parallel to the ground, or if you want it to be perpendicular to the tangent of the face at that point. And then you can also check the profile. So like I was saying, we have pretty typical circular or rectilinear already loaded, but we can create custom profiles if you wanted to create a tapered fin, or if you wanted to do something really funky with some nice shadow lines or reveals on it, you can do it there. For the sake of right now, we'll just keep it at rectangular. And then thickness and width. So the thickness is how deep the mullion is. That's how far away, how deep from the face of the surface it will actually go. And then the width is how far to the right or to the left, or for a horizontal mullion, how far up or down from the center line of the grid you want your mullion to be. So to show kind of what the difference is, let's do a 3-inch width on one side and a 1-inch width on side 1 and 3-inch on side 2. And let's just make this 6 inches just for the hell of it. Press OK. And then it will change our mullion a little bit. So it's made it a little bit thicker. Now, because it's centered on this this host, the 6 inches are coming off from the center of the face. So if we look, right, so it's basically going 3 inches that way and 3 inches that way from the center of the face. And then the 1 inch on side 1, as you can see, if I can tab in and grab that. Here, let me see. So I can visualize this for you guys a little bit better. So that dashed line, oh, there it is. That dashed line that you see, that's the grid. And so the mullion, we offset or created a thickness of 1 inch on one of the sides of the grid line and then 3 inches on the other. So that's that kind of asymmetrical, that's why it's asymmetrical off the grid. So if we wanted to, let's say we wanted to put a vertical fin system on this surface, what we can do is go in, manipulate the test. Let's create a thickness of 18 inches. And then it's kind of weird to offset or have it's very atypical to have a mullion offset from the curtain grid because that's where you dimension all of your panels. So let's just do a simple 1/2 inch on one side, 1/2 inch on the other, and hit OK. So we've got a pretty nice thin fin, but you typically want your shading devices to be on the outside of your building. You don't want half of it to be inside, half of it to be outside. So if we go in, go back to the edit, and we offset half the distance of the thickness, which would be 9 inches. Then it's now going to offset to the outside and create that fin on the outside. And then if we go in to the curtain system itself, so if we click the actual curtain system, go to edit type, and change the interior mullions from none to our test. Let's see if it will change. So we'll change all of those interior mullions to our fins and create somewhat of an interesting shading device pattern on our complex geometry. The one thing that you can also manipulate in mullion, and remember, and I think I've gone over this before, but when you have a curtain wall or a curtain system, this pin right here, that is telling you that the mullion or the curtain panel is tied to the family itself. So if you go into the family, the curtain family, and you change it from test to 2.5 inches, then all of these mullions are going to change to the 2.5 inches. And if you unpin this, you're unlinking it from the family. So if we go in and change this back from test to 2.5 inches, press OK. Because we unpinned it, it loses its link to the family, and all of these get changed except for this one. So when you're working on a project, be cognizant of that, because if you do run into a couple that didn't change, the likelihood is you forgot to pin it. And if you want it to be pinned, all you got to do, you don't have to go in and change it back to 2.5 inches. All you have to do is hit that pin, and it will change back to whatever is associated to it in the family. The other thing that you can manipulate, which I was trying to get to earlier, so if we unpin this so we can go in and edit it, if you edit type, of the mullion itself, you can change the material, which is pretty, I hope that you guys would be somewhat familiar with this at this point. But if we wanted to change it to copper for whatever reason, we can do that. We can change the appearance. So this is a copper material. We can go in and use the rendered appearance, which is this weird orange. Hit OK. Now all of those change. So you can do that to pretty much any mullion that you create, that you want. Oh, the other thing. So let's go back. Let's go back to our curtain system and edit type. Let's change the interior type of the grid 1 back to test. Hit OK. Get those vertical fins back. Oh, and we unlinked it, so that one didn't change. The other thing that we can do is we can go into the mullion and we can change the angle, right? So if we change this all to 45 degrees, then all of these change 45 degrees from the tangent, which is the perpendicular axes or vector that are coming off the panel at that specific point. So I don't know if it's apparent yet, but these are the type of parameters that we can start to control with scripting. So when we get into Rhino side, we start to apply some Grasshopper scripts to the Revit projects, Revit walls or elements. These kind of parameters, the angle parameter, the offset parameter, the different thickness parameters, these are all things that we can start to manipulate and develop scripts around that can then start to manipulate the geometry and create these more, I know it's cheesy, but parametric designs, right? These flowing designs, gradient patterns, controlling them based upon the sun location, the highest environmental performance, etc. These are all where we start. And we can actually build families, and we'll do this later on in the semester. We'll build families with these parameters in mind that we want to control with scripts. So that, oh, and I didn't even get into panels, which are pretty similar to mullions, right? So all of these are linked to the system, the family itself. If we want to unlink it or manipulate the panel, we got to unpin it and then go in. There's not as many parameters for panels as there are for mullions, but the ones that we do have are pretty similar. So offset, so this is how far away from the face of the surface it is. So if we change it to like 3 inches, we can change the thickness of the panel, and we can also change the material. All right, so it just made a thicker panel. It offset from the face a little bit more. Not a huge amount of manipulations, but in the next series we can start to manipulate a little bit more and start to add a little bit more variation, more parameters to what I guess could be termed a curtain panel. But this is specifically for curtain systems, and these are more of the traditional panels. These are found more in traditional construction, where we're essentially panelizing the system and faceting curved surfaces with straight, flat panels. So this is curtain systems. In the next video, we'll get into curtain. What are they? We're gonna go over divide surface. So we're essentially gonna create some more mass surfaces. We're gonna divide the surface and show you guys how to create different patterns that break away from the typical rectilinear orthogonal patterns that are typical in or restricted to in current systems.